You're listening to the Chorus One podcast, a show that covers decentralized networks and their impact on the evolution of automated and borderless economies. On this podcast, we invite pioneers and builders to discuss the decentralized protocols and projects they are working on. On the show today, we have Hendrik Hofstadt, Director of Digital Assets at Jump Trading and core contributor to Wormhole. Wormhole is a simple, generic protocol that delivers a pathway for any kind of information, funds, votes, programs, and more from any blockchain in the network to any other. In short, Wormhole acts as a notary that allows message passing between networks. Recently, Wormhole announced they would launch version 2 of their network, which will go live connecting 4 networks: Ethereum, Terra, Solana, and Binance Smart Chain. Wormhole has a set of 19 validators known as guardians, which attest to finalised chain state in a peer-to-peer network that is verifiable. 19 guardians publish a signature if they see a finalised message being posted on a network, and Wormhole network aggregates the signatures to produce verifiable action approvals, otherwise known as VAAs, to be consumed on other networks. In a way, Wormhole acts as a light client itself on networks it connects to. This podcast is a deep dive into one of the hottest networks of 2021. Tune in to hear all about the origin stories, the intricacies of the network, how it can be used, what's to come in the future, and so much more.
Hello and welcome to another episode of the Chorus One podcast. Today, Xavier and we are here with Hendrik Hofstadt, Director Special Projects at Jump Trading. Hi, Hendrik, and welcome to the podcast.
Hey guys, great to be on.
Yeah, Hendrik, so you have like a big background in the crypto ecosystem and have worked on like multiple projects, most recently the Wormhole bridge, which is what this podcast will be about. Maybe you can go a bit into how you got into the crypto ecosystem and where you are at today.
Yeah, sure. For the last 2 years, I've been running Certus One as CEO. We were a validator company, just like you at Chorus, and we've also been doing a lot of security research in this space. This is actually how I originally got into the space. I had a cybersecurity background, and I found smart contracts extremely exciting. And that also essentially what went hand in hand with like how Certus One was operating, because usually what we did when we joined a network as a validator, we did like a very deep dive into the protocol, really trying to learn how it works, try to find vulnerabilities. We reported a bunch on quite a few of the networks we were operating on. For example, Cosmos, we've been involved there from very early on, but also Solana. And over the time, as we've been doing research in Solana, we figured out that, especially last year with the launch of Ethereum, there was a need for liquidity on there and liquidity of tokens that just were locked and isolated in other ecosystems. And that is how we took the step and went from being a validator and security researchers in the space to actually building an own protocol, which was the Wormhole protocol.
No, very cool. And I think, totally, relevant to today, with Solana, it's been pretty hyped, especially in recent months. And it's really cool that you're working on something that will really bridge even more assets to Solana. So I guess now is a really nice time to ask, what have you been contributing to with Wormhole?
Yeah, essentially Wormhole is a protocol that allows programs on the connected networks to exchange messages with each other. At the core, it does message passing. And this passing of messages can then be used to implement use cases like bridging Oracle data, bridging governance votes, and bridging tokens specifically. Tokens being like the ERC20 equivalents, but also the NFT equivalents on each of these chains. But yeah, at its core, the Wormhole essentially allows message passing. And the interesting thing is like Wormhole acts kind of like a notary at its very core, where contracts on chains can post messages to the Wormhole endpoint on that network. And then our validators that we call guardians will sign and attest this message. And then this message can be consumed on other networks, verified. So you can do like a unidirectional message transfer, but you can also do like a multicast model, essentially, where this attestation is taken to one chain or multiple chains and verified in all of them, or actually even verified off-chain. So you could also use this to verify the state of chains using an off-chain program without needing to run a full node.
All right. And basically, recently you launched the version 2 of Wormhole. And before that, there was already the Wormhole bridge, basically the version 1, right? Which had been live for a while and had some usage. Can you maybe explain what the differences are between the two?
Yeah, totally. So the V1 actually was quite different from what I just explained. The V1 at its core was a token bridge. So we built that specifically with token transfers between Ethereum and Solana in mind. So, but what we quickly realized was that we got a huge amount of inbound interest from people that wanted to bridge more than just tokens. They wanted to bridge NFTs, that wanted to bridge Oracle data. And we realized, okay, either we build a massive extension, make a massive upgrade to the protocol, or we go V2 and fix some of the things that we learned that we didn't do right in the V1 and improve upon these. And that's what we ended up doing. We essentially redesigned some of the core mechanics and made it a message passing protocol at its core. So we aren't restricted in what we can build on top in like additional use cases. So the V2 at its core is this message passing protocol. And then there's a reference implementation for a token bridge, for an NFT bridge that is also provided on the repository. And that's kind of changed with the V2. And also the V2 is obviously a little bit more flexible in how many networks it can connect to and how these communicate with each other.
All right, cool. And then there's since Wormhole V1 was already used for a while, right? There are some tokens that are already on Solana or on Ethereum that went through it. Now, do these need to migrate to the version 2, or is there? How do you imagine that to happen? Is there plans? Is it going to be like some AMM, or is there some other migration path that you can?
Yeah. With the recent peak in interest in Solana, obviously the TVL of the V1 that's still running has also spiked. I think there's about 300 million in TVL in there right now. And obviously we can't simply ignore that and just go ahead with the V2. So in the V2, there's going to be some migration path. More specifically, we've been trying to approach this in a way that we can just adopt these tokens. There's the big issue that the V1 side of it, like on Ethereum, is not upgradable, which means we can't simply take the backing assets on Ethereum, transfer them to the V2, and then allow people a straight migration path from V1 assets to V2. So the idea now is that there's going to be liquidity pools that without a fee will allow you to swap V1 assets into V2 assets on Solana. And we've got a bunch of partners that are going to be providing liquidity to these pairs to make the migration as easy as possible. Given Solana's cheap transaction fees, we expect there to be little friction in making that move. And the most common direction of movement was from Ethereum to Solana, as you might be able to guess. And so we can do the migration there. It's going to be cheap and fairly easy. So that's what's going to be happening. Otherwise, it's going to be different assets on there.
And so we've mentioned Solana a little bit already in terms of one of the networks that Wormhole really bridges. What are the other sort of networks that Wormhole will be interacting with?
Yeah, so the V2 core protocol is live already with connection to Ethereum, Solana, Binance Smart Chain, and Terra. So these are the networks that are currently connected to the core protocol. The token bridge itself hasn't launched yet, but is expected to arrive very soon.
No, very cool. And I think it'll be even cooler, hopefully, when Terra enables IBC and,
Yes.
I think,
Yeah.
So,
we totally think Terra is going to be our gateway into the IBC world. And I think it's very, very exciting thought to think that connecting to a single chain already allows us to utilize this other cross-chain and interoperability protocol.
Exactly right. And we actually have another question about that, which we'll get to a bit later.
Yeah.
In terms of interoperability on top of interoperability. But I think maybe going back to the core sort of product and protocol of it, So in the sort of white paper or the GitHub that you have so far, there's a lot to do with this thing called a verifiable action approval. And so this is something that validators do basically amongst each other, which you call guardians. But I think it might be interesting for people who aren't as familiar with Wormhole to sort of understand how important is this verifiable action approval, and how might you explain it maybe in a simple way for people to understand.
So essentially, the name verifiable action approval is a bit of a relic from the V1 times. What it means in the V2 essentially is a VAA is a signed wormhole message. So that's essentially the message frame containing like which chain was it sent from, which program sent the message, at what time was it sent, what's the like payload in data, like it's a message passing protocol. So what is the message? That's essentially embedded in there. And then obviously it contains the signatures of the guardians and sufficient signatures. So a super majority, meaning 2/3 plus of guardians need to have signed it. And then that's what we call a VAA. And essentially this is what you can post to other blockchains to verify there, to make sure that this message was indeed sent on this other network.
And this is a bit of a follow-up question to that one as well. And so, when you have these VAA and these sort of signatures that guardians are signing in terms of, what's happening or not. So in a Medium post that I actually read recently, you use the MNN, like multi-sig scheme, we call it. But there are many different sort of cryptographic primitives you can use. And maybe just without going too far into all the different cryptographic primitives. So why did you choose, this M of N multi-sig scheme for validators to sort of approve, let's say, and get consensus on these things happening? And what are some pros and cons of this?
So I think the first 2 weeks of the protocol, and the V1 was created, I think, within a 3-week essentially hackathon internally with us. We spent almost, I think, two-thirds of that thinking about which cryptographic primitives shall we use. The original version we had designed actually was using Schnorr signatures and threshold signatures there, with some hacks that Chainlink actually proposed in their blogs to make verification on Ethereum easy. What we quickly learned, though, is that distributed key generation is a process that is complex to implement and even more complex to implement correctly, with all of the abort scenarios where a malicious validator or malicious guardian in our case could stop the process or try to exfiltrate key material by misbehaving the protocol. So this requires slashing. And even a single validator would be able to cause significant damage potentially. And then there's obviously what I'd call systematic or scientific risk of some grad student just breaking what is a very, very new cryptographic primitive. So we've been exploring BLS threshold signatures, these Schnorr threshold signatures. I mean, there's also other mechanisms that use plain elliptic curve cryptography. But what we in the end saw is that the simplest way of being compatible with all of these chains, because especially ETH, even at this time, only supports a partially broken BLS curve for verification. We said SecP is SecP 256K1 is essentially what's supported on pretty much any of these chains, because most of them use it as their native signature format. So we have easy verification and cheap verification on ETH, which was core for the protocol, because ETH transaction fees are already considerably high, and then we don't want to spend another 200 or 300,000 gas just on the signature verifications. So essentially just attaching these signatures, because data is usually quite cheap, like transaction payload data versus data stored on chain. It made the most economic sense, and also from a security perspective, it made the most sense to go with the most simple model, which is simply an M out of N multi-sig schema, which is just attaching all of the signatures to the transaction to this VAA and verifying them on chain. This is what we ended up going with, even though obviously we are constantly looking at the developments in the space. And we're looking to scale beyond 19 guardians, which is currently the limit, because we just can't attach a megabyte of signatures to VAA and reasonably post it on chains.
Oh, I think, I think really interesting. Actually, we had Axelar on our podcast, in our last podcast, and even they were describing some of the different sort of distributed key generations, that happen and what you can use and do. And I think, maybe sort of somewhat interesting as well. So you have 19 guardians, like you mentioned. I'm not sure, is there any way that so does this M of N multi-sig scheme, does it scale well? Like let's say you add another 19 validators, is that acceptable? Would you have to use something new there? How would you go about doing that?
Yeah, 19's already pretty much at the limit of what we can do. For example, with limitations that we have on Solana in particular of the runtime, the 19 signatures alone already don't fit in a single Solana transaction, so they're already sharded across two. And the more we'd be adding linearly, we'd be adding more data, and we'd have to send more transactions. Which, I mean, clicking approve 4 times in your wallet is gonna get tedious, and beyond that especially. So we're trying to 19 is kind of the sweet spot we found, also in terms of what we can do in to have a reasonable gas cost on Ethereum.
All right, maybe taking it back a bit, how you came to build Wormhole. Basically, what inspired you to build it? Did you see some problems before that you wanted to fix, and maybe how does Wormhole address these problems? How is it different maybe than existing other interoperability solutions, or were there actually none before Wormhole?
Yeah, especially the inspiration for the V1 was we were very active in the Solana ecosystem. And I think one famous Saturday, Anatoly sent us a message of, there's this huge partner coming to our ecosystem and they want liquidity from other chains. And we're like, yeah, okay, well, who's this big partner? And what it turned out to be was the start of Project Serum. And we're like, wow, this is huge. And we don't have a lot of liquidity. We have, I think back then we had the centralized stablecoin mints for USDC. I'm not sure whether we had USDT as well. But besides that, there was no liquidity. But for a great central limit order book exchange, you also need to have the assets there. So that was how we started then over the next 3 weeks building the Wormhole V1. And then with the V2, obviously, it was mostly inbound interest that we had in guys, we need to bridge data, we need to bridge this and that between these and an increasingly larger number of chains. And we saw that a lot of the bridges out there focused on token transfers and token swaps oftentimes as well, which I mean it's a great utility, being able to swap and get a native representation of that asset on the other network if there is one. But specifically for being able to bridge more than just tokens, there was just a very limited amount of protocols out there. IBC being one, but IBC obviously only connecting to Tendermint-based chains at that time, and even now a very limited amount of consensus mechanisms, while adoption was happening in spaces where we had proof of work, and building a light client, a reliable light client for proof of work networks, keeping track of it on these chains is very costly. So that was one of the motivations. The other thing was that a lot of these protocols just did single links between chains, but not every chain could talk to every other chain connected to the network. Partially because a lot of them were using light client implementations and had to maintain, verify each other essentially. Each chain you wanted to communicate with, you needed to verify. Otherwise, you needed to go through multiple hops, which in turn took very long. So that was also one of the motivations, because the Wormhole allows direct communication between any of these chains without additional costs required.
No, very, very cool. And I think, I think it solves a massive need and problem in all of these ecosystems right now. So you mentioned actually a little bit just then, light clients, and, we have IBC already, which makes use of these light clients, let's say. So maybe I think it could be interesting for listeners. So how is sort of Wormhole different from how IBC uses light clients, let's say? And also with Solana, in general, it's quite tough, I believe, to sort of get these light clients up. So, how have you done that basically? Just some sort of context and all of that.
Yeah. A lot of the cross-chain communication protocols back then were essentially focused on full trustlessness, where the chain would essentially run a light client of the other chain, meaning verify its tethered chains and follow its consensus essentially to verify the state there and be able to verify state proofs like account A contains this data, or this transaction was made and was included in a block. And obviously this requires mostly any of these chains to track a considerably high number of headers of the other chains. So a lot of transactions required. And connecting more networks obviously takes more compute resources on that particular chain. And it's not very scalable, except if you're using a hub and spoke model like in Cosmos, where you essentially just wander through the graph, which is fine if you don't care about the latency of the transaction in between. So what Wormhole does is it doesn't use on-chain light clients. The on-chain contracts, the endpoints of Wormhole on each of these networks, can essentially just verify these VAAs and verify Wormhole consensus, which is just this M/N signature multi-sig scheme. And each of the guardians then, what they do is each of them run a full node for all of the networks we're connected to, and they just observe finalized state on these. This also means, contrary to a typical BFT consensus or protocol like Tendermint, there's no way that without a 2/3 plus majority, you could be able to even trick the network into thinking the state was different from what they see, and essentially tricking them into a split brain scenario. So this is essentially the idea. Everyone just observes finalized state, and independently of what all the other guardians do, publishes a signature if they see a finalized Wormhole message being posted on any of the chains. And then in the Wormhole P2P network, they aggregate these signatures, collect them, and collectively produce the VAA then. So no light clients involved at all. Essentially, what you could say is the Wormhole is a light client network in that it produces light client proofs of other chains, but they can all be verified by following Wormhole consensus versus following all the different chains' consensus, which is also what I mentioned with, you could verify this off-chain. Like if you want to read messages from Ethereum, Binance Smart Chain, okay, similar consensus there. But Terra and Solana, you have 4 different consensus mechanisms. BSC has different consensus than ETH. So you'd need to implement 4 different kinds of follow 4 different chains, run 4 full nodes. With Wormhole, what you can do is just follow the guardian set changes of Wormhole and verify these VAAs for messages from all of these chains. And it's always going to be the same format. It's very easy to verify them, very lightweight. That's what we're trying to approach there, because we don't care how fast the chain is moving. As long as a full node can keep up with it, these guardians will be able to observe state and they will be able to produce their signatures. So even in a network like Solana, where it's quite hard to build a light client. I'm not sure whether any working light client implementation even exists at this point. But even there, obviously, we can observe state and publish these signatures within the network and thereby do the message passing.
Yeah, very cool. Maybe going back a little bit to the guardians that seem to be of course, a key ingredient here. And we mentioned that there's 19 right now. Can you go a bit into how these were determined and maybe kind of how do you see that develop, if you can share anything, or if there's plans to, I guess, scale them or how they can be kept? I guess there's still some trust assumption in the guardians, right? How do you basically make sure that they don't?
So the way we originally they were originally picked, so it's a POA set, especially in the V1. What we did was we looked at which parties are incentivized, to make this bridge work. That was more of the spirit of the V1. Who's interested in the success of a connection between Solana and Ethereum? So obviously, we had a bunch of foundations that were connecting, that were interested, but also obviously the validators in these networks, which are usually strongly aligned or were early investors. So there we essentially in this POA set, it's more of a proof of reputation in how we initially picked them, because obviously, and I mean, this applies to pretty much everywhere in POS. POS doesn't just have the component of stake and slashing, but the true slashing happens at the reputational layer. And this applies to the Wormhole set as well. All of these companies are very well-known proof of stake validators, very well-known foundations that are running blockchain protocols. Or Jump Trading was a guardian of the V1, or is a guardian of the V1 as well. Is a large institution with a huge risk in damaging their reputation. So this is essentially how it was picked and how we thought back then when we picked it, it was a very secure choice. of picking these initially. And these 19 now essentially form a DAO. Because they are the ones that govern protocol upgrades. They are the ones that could make a change to the Guardian composition. They're the ones with a 2/3 majority that can swap out that. Or they could replace it with a proof of stake mechanism in the future. But essentially for the first days, having a very well-known set with this proof of reputation, I think is a very good start. And as the protocol grows and as the protocol develops, it will naturally develop into whatever the users and the community deems the most important.
Yeah, I think that's, totally true. And I think, really interesting with Wormhole is you've sort of created this, sort of base layer, let's say. I think what's exciting is what you can build on top of it. And so maybe we sort of might take it in that direction a little bit now in terms of who has been building or who's using Wormhole. So Pith is this protocol or network, let's say, that is sort of the first competitor that Chainlink could said to be have had, basically. And so Pith, are they using Wormhole? Other networks, let's say, using Wormhole like Pith? How can you sort of see this coming together, and what's exciting you right now with what's being built on Wormhole?
Yeah, I thought just recently Swim Protocol made an announcement that it'll be building on the Wormhole v2, utilizing the message passing and token bridge to do cross-chain swaps. So this shows that like a lot of like behavior that is out there in other protocols can be replicated on top and make use of this network and of the connectivity, make use of all the networks the Wormhole core is going to expand to. And then obviously you mentioned Pith. Pith is an Oracle protocol, which is streaming extremely high fidelity and high resolution data to Solana at the moment. And essentially this message passing can be used to post these prices to the Wormhole contract. And the Wormhole network will then produce signed price statements, essentially, that can be bridged to other chains or also be consumed by off-chain actors that don't want to run a Solana node and just want to verify it across the via verifying the simple multi-sig scheme and signatures on the Wormhole message. So these are the two big use cases, and obviously I personally expect there to be a lot of usage of the V2 token bridge. This time, we as Jump put a lot of resources behind that and contributing to the protocol and making sure we're building a very smooth UI and contributing to a very smooth UI experience on the token bridge as well, and building a very solid reference implementation of that, and making sure that a lot of the, let's say, failure modes of like your internet cuts out while you're trying to do a transfer, all of these are actually met, which is something where we came a bit short on the V1. As essentially we sort of built the backend and then the community was building a UI, but no one ever really fully focused on any of these UIs. So the experience lacked a bit. That's going to really change with the V2, where there's a dedicated team being like almost being full-time on contributing to the protocol and helping make the open source protocol very, very successful.
So we did mention a few networks already, right? That connect to the Wormhole, and I guess maybe what would be interesting is how do you see this develop in the future? Which other networks might Wormhole extend to? Is that something that like maybe also other parties that contribute to Wormhole could extend Wormhole to? Is there like some kind of way for people to do that? And maybe what would be the incentive for someone to do this?
So when we talked about the guardians, them being reputable institutions, obviously, and them governing the protocol, obviously the guardians are the ones making the decision of which network is added on the sending side. And that's a very important differentiation we have to make here. Sending requires all of the guardians to obviously run full nodes for the network. Like you're a guardian, so you could propose to all of the other guardians, hey, we want to connect to, let's say, Polygon now. So if all the guardians can be convinced, or 2/3 plus can be convinced to run nodes on Polygon, the protocol can add that and you can propose an upgrade and make that happen on the network. So the Wormhole protocol at its core is fully extensible to new chains. And there are definitely plans to add more support to other chains, different consensus mechanisms in the node software as well. No specific candidates I would be naming right now, but everyone out there could, like any protocol, like if a core team is interested in connecting to the Wormhole, Wormhole is a fully open source project. You can go ahead, look at the reference implementations for that, look at the design documents and the protocol architecture, and implement this into the Guardian, implement a Wormhole compliant endpoint for their specific smart contract runtime, or even build it natively into the chain. That is totally possible. And actually, I find it extremely exciting, especially with projects like Pith, where there is this stream of attested price data being sent to the Wormhole network, like as a constant stream, essentially. And in order to consume Wormhole data, there doesn't need to be support by the Guardians. As long as you build a smart contract or deploy the existing smart contracts, like we have ones for the EVM, we have ones for COSM WASM, and there's a Solana implementation. If there's any network that can run one of these, as long as someone relays the Guardian set change VAAs, so they can follow consensus essentially, Wormhole messages can be verified even on networks that aren't officially supported by the Guardians, because essentially it's just verifying the multi-sig schema and being able to parse the message. So even a network that isn't like with higher effort considerably connected to the Wormhole can consume messages and potentially can consume PIF data or another protocol's data that is published to the Wormhole.
Yeah, actually, I was wondering, because I guess this also, again, from the Axelar podcast, where in there, I think basically the validators don't need to run all the chains that are connected. So you can basically like choose which one you connect to. I guess on Wormhole, it is the case that everyone has to accept everything. So like if there's one kind of Guardian that would like refuse to add a chain, would that like make it impossible to add that network then? Is that basically, or?
So obviously in the longer term, there are ideas in the place in the community to transform it to more of a traditional DAO-owned, make it a more traditional DAO-owned protocol with on-chain voting and so on. But for now, technically 2/3 plus are sufficient to make this happen, because then you can like get a quorum and get a valid Wormhole message. Obviously, if one of them fails, then we're going to lose liveness on this particular chain. So right now, there's action required, like ideally, and consensus ideally across the participants in the network. We always follow this into like keep it simple and stupid in the protocol, so it's very like easy to audit, verify, and understand by everyone, and like thereby also increasing security of the protocol. But over the longer term, I think there are opportunities to also do partial Guardian sets. Right now, that wouldn't be possible.
Okay. Maybe also, one other thing, if we now, like if the token bridge is there and let's say I move through the Wormhole from Ethereum to Solana and then from Solana to Terra, will it be the same token as if I go from Ethereum to Terra, or do I have like a lot of tokens then, or how do we handle that, I guess?
Yeah, so the token bridge reference implementation that is on the Wormhole repository has fully universal wrapped assets. That means if you do a transfer, as you said, let's say from Solana to Terra to ETH, and then from Solana to ETH, you're going to get the same wrapped asset. And that's always going to apply to all networks that are connected. Like implementation-wise, essentially, when you do a transfer, you are not transferring, like if it's a Wormhole wrapped asset, it is transferred using the metadata. Like every chain knows where this asset originally came from. It stores the address and a Wormhole specific chain ID. So when you bridge between two networks and bridge an already wrapped asset, it contains all the metadata necessary for the other network to recognize this. Oh, okay, this actually comes from Solana. So this is this wrapped asset. So we'll have universal assets. And in the VU2, that's also something that has changed, is metadata is bridged across chain, meaning symbol and name of the token. Which I think is going to be extremely helpful for adoption of these tokens. As in the V1, essentially, I think the name on Ethereum was just a hex encoded address, which is very questionable, like user experience wise. And I think we've improved a lot on these things with the code we've pushed.
And I think maybe this is just sort of dreaming at the moment. But, if you had some asset on Solana, let's say, and you bridged it to Ethereum, then with other new interoperability protocols or networks coming out, such as Connects, let's say, on Ethereum, and also because it's the same token and you know what it is, it's pretty cool what you like, just thinking about how these interoperability networks will actually end up sort of utilizing each other and leveraging each other's benefits, which I think is like super cool. So yeah, I think basically it's really, really cool. I think everything like you've said, Wormhole itself is such a unique network. I guess what might be interesting to hear about is where can you sort of see this going in maybe the longer term? Now I know it might be hard to say, obviously, because things change all the time. But could you see people sort of, is it like sort of someone builds this, then they build on top of that, and it's like sort of Legos like that, or could you see it more going horizontal, so to say, when you go more networks rather than building on top of applications? How could you sort of see that?
Yeah, I mean, I can't foresee what people are going to build on top. So I'm extremely excited. I was already very excited when I saw Swim announcing they're going to be making use of the core protocol. I'm very excited about Pith using it for data bridging. I think core development wise, I mean, we're core contributors, so we're focused on obviously extending the usage of the use cases for the core protocol first, responding to feedback. I think there's going to be a lot of feedback with the token bridge launching. Maybe like the protocol is never perfect, and there might be blockers in the core protocol. It's fully upgradable now in the V2. So there might be changes required there, just maintenance. And I think maintenance is something I really want to stress, in that this is one of the big focus points here, is building something that lasts and that is actively being improved in its core, and like in not losing the focus and trying to build too many things, but focusing on the really, really important things, while also like experimenting with new things. Like, for example, I think we just recently, like last week, pushed an adaptation of the token bridge that can do NFTs, which like has been super hot on Solana. And I think like these things, like highly demanded things, are what we as contributors from the jump side are going to be focusing on, like maintaining the core protocol and building highly demanded, exciting use cases. And then I can't foresee what other core contributors, what guardians, like maybe you guys, are going to be building on top. What I'm quite excited about is more of a IBC-ish, TCP-ish model with essentially message received acknowledgements, so you can know whether a message was actually processed on the other end, which I think could include a relayer network. Like, as I said right now, Wormhole messages are just attested and signed, and then in the case of a token bridging message, the user is expected to essentially publish that message to the other chain as a kind of check to get their tokens on the other end. I can foresee a bunch of use cases where you wouldn't be owning a wallet on the other side, and where a relayer network might be necessary. And then you can layer things on top, like this relayer protocol could allow you to post messages, and essentially they add a little bit of information on the recipient, intended recipient of the message, and then your payload is added. Like you can, just like in the like traditional OSI model world in networking, you can layer multiple network protocols on top of each other, building on the primitives that are there. And I foresee and hope that a lot of that will happen with the Wormhole.
No, I think that's super exciting, and I might have sort of a question I might sneak in as well. Will you be the first sort of bridge of NFTs between like BSC, Terra, Ethereum, Solana, or is...
To my knowledge, this would be the first NFT bridge in that space.
Very cool.
But
Very cool.
I'm not 100% sure, obviously. I would be surprised if no one was working on it right now, given how hot the space is.
Probably, yeah. Yeah, so I guess we can wrap it up soon. And thanks so much for coming on. I wanted to ask like one kind of final question, since we've been like exploring the Wormhole Token Bridge 2 as we launched Lido for Solana, and we were like planning to move the Lido tokens from Ethereum to Solana, and later probably also the staked Ether and the other assets amongst the networks in Wormhole, as they are all kind of networks that are also supported by Lido right now. And I guess you already mentioned that there was like 300 million TVL from Wormhole V1. Maybe you can share a little bit of kind of who do you expect to be like heavy users of Wormhole, or what was until now kind of the main route that people went. I guess just like some insights there would be interesting to me.
Yeah, I think if we look at the Ethereum Solana route, I think the three main current ways of transferring tokens were either the Wormhole V1, which, for example, been used by Saber Protocol on Solana for some of their stable pools. Then there was the centralized FTX/Alameda/Solid bridge that was built right into the Solid wallet. I think that also had a lot of adoption. And obviously there's Ren, but only for a limited set of tokens. I expect that obviously the V1, like a lot of the V1 traffic will migrate to the V2, especially for its significantly better UX. And also generally, I think that people prefer a nice decentralized bridge over a centralized bridge, or well-built decentralized bridge over a centralized bridge. So I would also expect a lot of the solid flow to move over to the Wormhole V2 in the near future. But I actually expect most of the new usage to come from the improved usability, from like having token names on there, to also get more flow in the other direction of bringing Solana native assets, where there are a ton launching right now, to the Ethereum space and Ethereum Binance Smart Chain, DeFi space. But I also expect a lot of new inflow to be happening, as like the Wormhole V1 was never like publicly announced with a UI. Like, this is the reference UI, go use that. This is the protocol, here's a guide. It was more of here's a piece of infrastructure, go build on it. And this is going to be different with the V2, obviously, where the V2 has a very solid reference implementation. I hope that a bunch of people will launch like protocols based on these reference implementations. And I expect let's say, canonical implementation to evolve sometime in the future of this token bridge, which is going to be like, with this much better maintained code base, is going to be a lot more usable and attract a lot more eyes and make a lot more protocols feel comfortable in telling their users to make the move, in making wallets more comfortable and making the integration and moving their assets over. I think this is going to be what might be happening, and that a lot of new flow comes versus like taking flow from other ways.
Very nice. I think, Hendrik, we might wrap up for today. I think it's been absolutely fantastic getting insight into all of this, especially, with how busy you must be at the moment. We like fully appreciate your time, and, we
Thanks.
can't wait to get involved and support Wormhole as a guardian, first of all. And then who knows what will happen in the future. But so thank you so much, Hendrik. And yeah, maybe just to finish off, if you don't mind dropping maybe, where people can find you with Wormhole, or even maybe yourself.
Yeah, you'll find all of the socials linked on Wormhole Crypto on Twitter. This is the main place, and from there, the Discord's the most active places, especially for developers as well. They're planning to use the SDK to make an integration. And yeah, Felix, Xavier, was really great being on. Thanks for having me, and looking forward to also working with you on Lido over Wormhole.
Thanks
so much, Hendrik.
Thanks. Bye.